Welcome to the 5th plenary session of MINEX Kazakhstan Mining and Exploration Forum 2023. Kazakhstan has taken significant steps towards modernizing its geological industry. Companies are embracing innovative exploration methods to improve the quality of valuation of prospective areas, and to determine the best methods for their development and production. Given the vast areas of Kazakhstan, the effectiveness of geological forecasting and exploration largely depends on the use of advanced technologies, comprehensive analysis, and the high competence of specialists. In line with this, the Kazakhstan strategy, launched by the government in 2012, identifies social, economic, and political reforms aimed at placing Kazakhstan among the top 30 global economies by 2050. The growing economy and the emerging opportunities for the development of critical raw materials in the country has also driven up the demand for a highly skilled workforce for the technologically advanced mining enterprises. Modernizing the geological industry is critically important for Kazakhstan's long-term economic development and achieving its ambitious state plans. Join the session to participate in the discussion on how advanced technological solutions can significantly improve the efficiency of forecasting and exploration of mineral deposits in Kazakhstan.
Welcome to session number 5. Efficient technologies for forecasting and exploration of mineral deposits. Before the session, you had an opportunity to answer the question, which technology gives the best results in terms of speed and economic efficiency in the exploration of mineral deposits in Kazakhstan? And 75% response were that it's application of complex geophysical methods in exploration of deposits. In the century, when we have a lot of information, we need to improve efficiency and utilize new technologies in exploration. During this session, you will have an opportunity to listen specialists that are using that technologies in their practice. And to start our session, I would like to invite our first speaker, senior geoscientist Rio Tinto Saken Balatbekuli. His topic will be Pribrizhny case study of multi-physics application in copper porphyry exploration. Please, the floor is yours. Hello, everyone. Please speak close to the mic.
First of all, I would like to say thank you to my company to give me this opportunity to present this paper, and big thanks to all my colleagues who were supporting me to preparing these presentations. The topic of my presentation is case study of multi-physics application in exploration of copper porphyry targets, Pribrizhny tenements. Also in this photo you can see our camp in approximate close to the exploring site. So as you can see, everything is under the cover. There is a short context of my presentations. Most of the time that given to me, I'm going to talk about different type of geophysical survey. So hope that I will cover everything. Pribrizhny deposits are located in 600 kilometers far from Almaty to the north, and just 30 kilometers to the east from Balkhash city. So, as I said earlier, everything is under the cover. Intrusive rocks are dominantly carboniferous Mansa granite with 330 million years of age. Pribrizhny sits on the western part of Central Asia, big orogenic belts, and which includes the known copper porphyry deposits such as Aydarly, Aktogay, Borly, and Konrad. Pribrizhny discovered by testing alluvial sediments in low MAC features and explored by two main campaigns in 1976 and 1983, where actually two mineralized bodies were found in the northern and southern flanks of the deposit. But due to some operational difficulties, further exploration has been stopped. There are 6 major lithology ways has been evaluated domains. All of them are carboniferous. So first it's foliated monzogranites with foliated fabrics, amphibole biotite tonalite, coarse granite toporphyric monzogranites, phreatomagmatic breccia, rhyodacite porphyry, and pinky monzonite with biotite altered to chloride. Regional gravity at Pribrizhny showed that the copper porphyry deposits is located on the measured gradient zone between 2 high gravity features with a significant extent. It lies on a significant northwest and southeast trending structures. These structures orientation are also recognized as a deposit scale and post-mineral movements. In these slides show different type of geophysical surveys that we have done for the 4 field season. So I'm going to talk about this in detail. While the magnetic method doesn't map it directly mineralization, but it has been proven effectively understanding the structure control and distribution of hydrothermal alteration. In Pribrizhny highlights 2 main textures outside of the low mag, roughly cutting the area into the 2 zones. Into the zone. Northeast and southwest domain. Most mineralized ore body sits outside of central low on the northern edge and with a smaller mineralized zone on the south. After the ground mag survey, dipole profiles were designed across the northern half of the magnetic low map to map chargeability resistivity zone. Chargeability response clearly defines the spatial distribution of sulfide mineralization, and the resistivity data supported to mineralization at the depths and to map the cover thickness. Sorry. Further, in 2019, 3D DAS IP survey was completed over the whole tenements. Distributed array system thus offered more resolution, reached great penetration depths, offering a better new surface resolution and very cost-effective. Chargeability response represents the approximate margin of sulfide distribution of the northern and south zone. These anomalies are present with 50 meters of surface and continue to the bottom and inverted section with a nominal depth penetration around 500 to 600 meters. In these slides, you can see integration of geological and geophysical data. So how can it help us to determine and map some possible structure and mineralization? Another example of data integration. So generally in Pribrizhny, we can say that everything is structurally controlled. In 2020, a multi-transmitter vector IP and MT survey were conducted over the Pribrizhny tenements to map out additional porphyry targets. VIP and MT data were collected with nominal 1 kilometer grid size to characterize the distribution of the chargeability and resistivity parameters to nominal depths of 1 kilometer. This method is good in terms of timing and costing, possibly to cover large area in a short time. From the VIP survey to chargeability coinciding with the vector average resistivity anomalies on Conrad East and Shulak were observed. To improve the resolution of a VIP survey from the higher spatial density of receiver stations, single profile of pole dipole IP were completed over those two potential interesting targets. Pole dipole IP over the northeast Conrad relieved a shallow chargeability target, which was interpreted to be from the cover and possibly clays and weathered zone. Shellac was drill tested, and hydrothermal alteration are represented by moderate silicification on the ground mass. Finally, diffused magnetite is noted by ground mass, while there was no significant copper contents. Sulfide intersected, and petrophysics and logging of the hole confirmed that the VIP anomaly was adequately tested. So given that the Pribresny is completely under the cover, petrophysical measurements, IP, resistivity, density, and magnetic susceptibility were completed on the drill core samples. And generally, we can say that the tonalites are most magnetic and resistive out of all lithology. Rhyodacite, porphyry, and monzogranites have the lowest magnetic susceptibility. Foliated monzogranite and monzogranites are most chargeable, followed by rhyodacite porphyry. The data has been principally used to constrain inversion of the ground magnetics and confirm the IP anomalies observed during the survey. For resource estimation and hydrogeology studies, determining the overburden thickness was critical for the project. To rapidly estimate the cover thickness to horizontal to vertical spatial ratio of ambient seismic noise method by using one or more exciting drill holes was used, simply to say passive seismic survey. So this method matched quite well with the depth of cover. So last one is a downhole geophysics, was completed in two phases. First, to aid structural logging, geotechnical data and lithological identification, and second, to try classify the different type of veins. ATV, OTV, natural gamma, full wave sonic, and 3-arm caliper were used on the program. Integration of multiphysics techniques with geological knowledge and petrophysical measurements is critical for effectively exploring and delineating the blind deposit. As the volume of these data sets increases during the project lifestyle, the knowledge of the deposit, physical and chemical signature will improve, thus enhancing the success rating of finding additional mineralization. The Pribresny copper porphyry demonstrates how multiphysics can assist in resource delineating, targeting and finding deposit under the cover. There is still plenty of opportunity to discover mineral deposits under cover, and early acquisition of petrophysics will help in the integration of geophysical data and integration with geological data. Pribresny remains a large, low-grade porphyry deposit with the potential of long mine life. Geophysics must be viewed holistically within the exploration program rather than a series of discrete projects. In a covered terrain, a single geophysical technique really discriminates geological components of the system. So this demands of multiphysics approach to ensure optimal integration and integration into exploration program. Recommendations were taken from reference and material presented of the slides. Last slides, also would like to express my gratitude and big thanks to our colleagues who was supported us during all this year and carry out all this survey successfully in high level. It's a NAMAD Geoservice, Southern Rock Geophysics, IBTV Geophysics, TGI Geoscience, Resource Potential, and our long life partner, Geology. Thanks.
Большое спасибо, Сакен Балатбеку. Отлично.
Thank you, Saken Balbekulu, for great presentation, for having shared your experience. As we have 8 speakers and we have strong agenda. If the audience have questions to Saken, you're requested to ask a question at the end of the presentation. Thank you very much. And I have also my colleagues, and you can also ask them questions, as we would need to listen to 8 speakers today. Until now, I am announced the second speaker. It's the Vice President on Business Development, B2B Geophysics, Chris Nint. The topic is polarization caused by Das Vision 3D example from Canada and Kazakhstan. And also this, we have to remind the speakers that we have 8 presenters, and you can't be requested to speak within 8 minutes and speak close to the mic. Thank you.
Pleasure to be back here after 4 years in COVID, and I thank you very much for the opportunity to talk to you. And it's a real pleasure to visit you again. I want to tell you a couple of additional case studies of Das Vision 3D IP. Just to start with a brief summary or explanation of what we do. We put a remote electrode out at distance, and in series we put a full waver, which is built by Iris Instruments in France. It records and monitors the current, and then it's in series with a transmitter, and then then on to the survey, the study area. And within the study area, you transmit at various locations within the mesh of receivers. Each receiver is independent. They're not connected. Each receiver has 2 dipoles. Those dipole lengths can vary. The previous case study that you saw in the last speaker, the dipole length was 200 meters. You can lay these receivers out in batches of as little as 10, as many as 60, and you inject current throughout the grid, the mesh, and then you invert it all together. So the previous case studies, the Prebrezhny case example was 200-meter dipoles. We can shorten the dipole length and get more resolution and higher, but not as deep. So I'll start with a 50-meter dipoles example. This is an example from Canada. It's an iron oxide copper gold deposit called, Jovan project. It's 40 kilometers west or east, of Thunder Bay of Sudbury, Ontario. There are several past producing mines in the area. It's high-grade polymetallic gold that's associated with iron-rich veins within an albitite host rock. The targeting priorities would be conductive in nature and with some chargeable association. So we use a metal factor parameter which best describes this target. This shows the layout of the ORVision or the Das Vision receivers. They are in the blue there with the little dual dipoles you can see on each receiver. And the red triangles are the injections. The one advantage of Das Vision is that it's flexible. You can lay out these receivers you can modify to avoid lakes and rivers and people's houses and things. You don't need to be of a regular grid. You can just be approximate. Each receiver is controlled with a GPS. And then everything is collected and merged all together in a great big 3D inversion. The metal factor, what we call metal factor, is actually defined as the chargeability divided by the square root of the resistivity. So if you have low resistivity and high chargeability, your metal factor is a high. So there's amenable to hosting disseminated sulfides that are associated with gold in sheared or faulted environments. In this case, you'll see the metal factor plan view on the right-hand side of the slide, and the drill target that was picked from the metal factor. And McDonald Mines press release, you'll see where the drill is, and you'll see that same shape. That's the metal factor. It's drilled targeted on the metal factor. And when they drilled it, they encountered highly sheared rock with massive to semi-massive sulfides, chalcopyrite, pyrite, and pyrrhotite throughout the metal factor trend. We don't have any assay results yet, but there's some of the core. The shear zone was defined using the calculated metal factor. The DAS vision survey was successfully modeled. One advantage of DAS vision over more conventional IP methods, 2D IP, is that the small survey dimensions, in this case is only 600 meters by 900 meters survey block, we could constrain all of our data. We didn't have to go outside the boundaries to get significant depth of penetration. And drilling confirmed the presence of mineralized shear zone. The second example, I now would step out to 100-meter dipoles, and this is a case study in another one in Ontario. In this case, it's 50 kilometers west of Thunder Bay, Ontario. It's the Tower Mountain property is located in a Archean greenstone belt. It's and you can see the big red star on the map there. It is there's a intrusive complex. The Tower Mountain intrusive complex is multi-phase alkaic intrusive. And the mineralization consists of broadly disseminated gold, which is associated with pyrite just surrounding the intrusive. The two principal zones, what the UV zone to the top of the slide to the north and the bench zone down to the south, have been drilled and mapped and drilled, and from surface, they were discovered by surface sampling and localized drilling intercepts. There are other little smaller deposits in the area, Ellen and A, and what we call 110. They wanted to see if they could see any deeper. So we laid out the three blocks of DAS vision overlapping by one, and then we merged it all together at 100-meter intersections. And you can see that down in the bottom left, the amount of data that we get for a 3D inversion. It's a tremendous cloud of data points. The highlights is that the bench zone is moderately intense chargeability. The UV, L, and A, and 110 zones were recovered as weak, but right between the Ellen and the bench, there's a chargeability high that had been unexplored, and if you look at the vertical section through the through south of the bench zone, on the left-hand side of the slide, you'll see that that's the IP vertical section south of the bench zone. In the middle is the IP section through the bench zone, and the IP's vertical section north of the bench zone is on the right-hand side. You can see they missed it completely when they previous drilling. Look at the center where the IP vertical section in the bench zone, they had not drilled into this. So they have now drilled into it, and in March the 20th, the Thunder Gold Corporation press release, they encountered visible gold at 941 grams per ton of gold between 125 and 127 meters. And in fact, you can see the visible gold right in the core there. So the conclusions is that Abitibi geophysics, the DAS vision 3D IP increases the utility and efficiency of 3D IP. You can get depth of investigation greater than 1 kilometer if you have dipole spacing, say, of 200 meters or 300 meters. Their receivers are not connected. They can locate them to avoid natural and man-made obstacles. Each receiver has 2 dipoles. The case studies, successful case studies using dipole lengths of 50 meters, 100 meters, and the previous speaker's example of progression, the 200 meter, have been presented. You can inject current in the surface within and surrounding the receiver mesh, but also if it's available, if you have boreholes in the area, you can inject current down into the boreholes, which improves your inversions. And I'd like to acknowledge Abitibi Geophysics, who I work for, and Nomad Geoservices, our partner here in Kazakhstan, and the companies McDonald Mines and Thunder Gold for permission to show these studies. Thank you.
Thank you very much, Chris. It was a pleasure to hear about the case studies. Thank you. Следующий спикер у нас
The next speaker is Senior Geologist of Geotechnology Institute, Andrei Chitalin. The topic is geological targeting as the most efficient instrument of prospecting and search for ore deposits, and you're kindly requested to follow the agenda and speak closer to the mic. Good afternoon, distinguished colleagues. The presentation is about geological targeting that we discuss as the most efficient instrument of prospecting and the search for ore deposits, and I'm from Company Institute of Geotechnologies. What is geological targeting? You know this term as exploration targeting, which is used by Western companies, and this is our Russian equivalent of geology with a geological targeting. This is a selection of best prospect areas where we have the highest probability to find the deposit with set parameters. What set parameters? When we are not looking what we can, everything that we can get. The company identifies the parameters of deposits that they may find that could be profitable to develop and use. So targeting is a business decision. We should know what we are searching for. Different companies have different targets, but based on the experience of companies, we are interested in big copper porphyrite and gold objects and deposits like pyrite, ores, and OSG on Olympic diamond. An example of the efficiency of targeting is the opening of big copper porphyrite deposit containing Smarmish at Khabarovsk region, and I have been participating in the discovery and prospecting of this object. We have been working with American college that came to Russia that years with a task to discover big deposits, and we got a task. You have to find and prospects area with resources not less than 2 million tons for open mining. For this, we drilled down geological foundations, we read all geological reports, and we identified 200 objects that could be appropriate for these parameters. So we have selected 40 best to visit areas in the field during 2 field season in small groups. We have visited them, and we found we selected 5 sections for 5 areas for licensing. It's at one of these blocks which appeared the best. We found Malmush deposits that has been forecasted by us, and then it was discovered in this current condition. The company or the deposit belongs to Russian copper company. The balance resources according to their data reach 8 million tons of copper and 350 tons of gold. And what is interesting is that at stage of targeting and first prospecting wells, we forecasted almost the same figures as a forecasted potential. We assessed 10 million tons of copper and 500 tons of gold. I believe that the resources of this deposit are still available, and new reserves will be discovered. The demand at targeting is very high. Every year we fulfill these works in Russia and sometimes in foreign countries. Now you see the map of our works, and this is the map of geological map of Soviet Union, where you can see the areas where we carry out geologic targeting for copper porphyrite golden and polymetallic ores. We work in Kazakhstan and Georgia, Tanshan and Kyrgyzstan. Our algorithm of targeting is based on the methodology proposed by Americans, but it is added with modern methodologies of surveying, and we are taking efforts to develop this methodology. And in any case, we're studying archive materials, primary materials.
And then we compile everything in one JS project, analyze, ranking it, then added imaging, interpretation of the space imaging, and then we select the best sites, go to the field, look at them, and then ranking them again to provide the answer, whether we can expect the best site here or not. This is our approach. Okay, desk targeting. This is the main one. We have to use all the available materials, take into account the references, dissertations, scientific papers. We all compile it in a vast.js project. These are several layers of geoinformation models. That's how we are using it. Here we are using geology, metallogenic, mineralization, geochemistry, and also taking into account different prohibited areas. Then we, during the desktop targeting, we are doing regional analysis using the database. We identify the mineralization trends, for example, in the West Chukotka, in the regional trend, we can see that this is the shear zones, and then by these shears we can prospect the areas with some signs where we can send the team for field visit. Then we get a lot of information from the large-scale maps, and then we analyze some nodes, identifying the structure, kinematics, and then we identify the areas where we can expect the big and rich ores to be accumulated. And then we analyze reports at the regional level. For example, in the central Kazakhstan sparse area, we targeted it 4 years ago, and so many years ago I was a surveyor there, and then we identify controlling structures, how they are located in the space, which of them are important or not. Then another part of the desktop targeting is a structural interpretation of geochemical and geophysical anomalies. It helps us to identify the prospects corridors where we understand the kinematics, so shear kinematics, and then we can more target the search of the ore. Also, we are using alignment analysis of the space imaging. We use less software, but now our company is developing its own software. Hopefully, it will exceed lesser by volumes and of the information to be processed, and in terms of machine learning. Also, we use a spectral array of the images. In Peru, for example, here we identified the porphyrite systems, and also we identified the structures of the mineralizations. In Australia, we also participated in the competition on the computer targeting, and we projected some deposits of copper and gold. This is the method that we try to develop as well. What is important is to be prepared for the field works. As soon as we identify the area, we collect all the details about the area, and then we design the route, because the better the route is, the more efficient you will be in the field, and will be able to identify more interesting things. These are the examples of our field trips to Khabarovsk region, north of Russia, Kazakhstan, central Kazakhstan. During the field targeting, we using express assay methods, using portable analyzes, putting them whatever it is possible, identifying minerals, chemical composition of minerals. It's very useful. Also, we use field hydrochemical methods because it helps us to identify the borders of the area. All the data fields are filled into the database. It is being infilled all the time, and then we can print the maps, identify details of the area, and so on and so forth. Also, then we identify the methods of drone imaging, to look, to search for the geological decoding, to look for geological structures. At every stage of our activities, we rank the targets, and the best target is in the top of our table. Based on the results of the targeting, we are selecting the best area. This is a small statistics. This is a targeting in Khabarovsk region and in central Kazakhstan, Spasskaya zone. In Khabarovsk region, the big deposit was identified with targeting 2 million tons of copper, and in Spassk region, the average deposit identified with targeting was 1 million copper. But the number of field targets is 8 times more than those that you identified at the desks. Conclusions: targeting helps us to save everything, improving geological prospects, reducing the risks. Looking to the future, what we can see that the targeting should be based on the computerization, because now we are dealing with big data. We have to use AI and process with this big data using computers and AI. Thank you. Thank you for your attention. Thank you. Thank you very much, Andrei. Very interesting, very presentation. Just to remind you that we have mics available, and at the end of the session there will be a Q&A, and you will be able to ask questions. The next speaker, CEO, Eastern Drilling Company, Andrei Popov, for improving the efficiency of geological exploration through the use of modern drilling technologies. Thank you. Okay, colleagues, how I can change the slides? Or please, you have buttons there. How I can turn on my presentation? Okay, that's it. It's here. Colleagues, hello, everyone. Thank you, everyone. The survey was very interesting, and all the money are spent for drones and for initial lithochemical aspects. That's the most of the money spent for. But when potential targets are defined, when we are defining where to drill, then for that aspects, not much money is spent. So the main expenditures are for the drilling, actually, during the exploration and utilization of the deposit. That's the topic of my presentation. About our group, Eastern Drilling Company, this is the part of VBK. We have 300 drilling rigs. We are the biggest drilling company in CIS countries. What kind of approaches we using for drilling? We use RC drilling. It is being applied in Kazakhstan and Russia. It helps to save time and save expenditures, and just during several months you can get enough information about the deposit. For example, if we use RC drilling, and if we replace this RC drill rig for other drill rig, then it will be not so efficient. That's why you can see here the examples. That's our examples of RC drilling for different depths. Okay, as I mentioned, we have a big fleet of RC drilling rigs. We have 12 of them. In the nearest future, we are buying the 13th one. Second area, and I would like to talk about that. It's more interesting topic. It's a novelty. We are talking about the directed multi-layer drilling. So here you can save a lot if you're talking about very deep deposit. So there was a deposit Sudbury. You showed the picture, and Glicor and Valia. They are doing extractions there, and about 30 rigs are working there, and the depth of the drilling is more than 1,000 meters, and of course 3,000 meters, and of course to drill the well 3,000 meters, it's a big expenditures, but how we can save the money? It's 50-60% of saving for the customer. There are different types of directed drilling. So the simplest ones, these are fixed devices. Then using the motors, and the most complicated one is telemetric drilling that are being used in the oil sector, but we are using these technologies from the oil sector in our mining sector. What is the directed drilling? Why we need to use it? Because first of all, we are saving money. You don't have to drill empty ores. Then we can use different angles, and especially if you're talking about the fallen rocks, especially that are peculiar for gold or deposits. But then I can show you the example how we are doing that. We can approach these layers so under specific angles. So we drilled 10 holes under the pits, under kimberlites, and the depths of the holes were 1,833 meters. The diameter was 63.5 millimeters. And here we use the Farak rig, and we used a Canadian telemetric system from oil sector. It's a unique approach that we used. We can be proud of that. Then Olympiadinskaya deposit, we were exploring it from 2020 to 2022. These are the holes drilled by our company. You can see the profiles of the holes. They are very equal. As you can see, the maximum depth of the hole was almost 2,000 meters. Diameter HQ. 22 holes, some of the grand holes, and we coped with this task, and then altogether 70,000 meters of drilling, but then we managed to reduce by up to 20,000 meters of drilling. That's why we saved. Actually, we saved the money of the customer because we drilled less than it was proposed from the very beginning. And the precision was about 10 meters, 10 or 15 meters. This was a very interesting project. Also, we are doing similar activities in Kazakhstan. We drilled about 200,000 meters in general. And we are using direct drilling because geologists ask us specifically to drill the target, and everyone wants to be precise in drilling. No one wants to have a wider grid. All the geologists wanted to have precision. So that's why if you are talking about directed drilling, it's a standard already almost, especially for our company. Very briefly, one of the presenters were talking about acoustic televiewer. It means that we are getting more information. We are providing this information to geologists. So we are using the code drilling. Another company, Master Detra, so they are drilling the technological holes and wells. So it helps to save. We drill the pilot hole, and then with this hole we provide air to the mine, or this hole can be used then for the existing mine for some purposes. So Master Drilling is the leading company. We drilled these holes together with them. They have 300 drilling rigs, and we are using their drilling rigs as well in Chukotka and Kamchatka. I would like to thank again our customers, our colleagues, and our partners using this occasion. Thanks to everyone.
Thank you for detailed technical presentation. The next speaker is servicing a geophysical company, GMM Service Evgeny Ermolkin, Director General Optimization Field Operations in ore deposits, prospects, and exploration. Good afternoon. I am representing Service and Geological Company. I lead. The topic of presentation is very relevant, optimization of geological exploration, and I show you one of successful works of GM Service, and then we will discuss optimization in general. One day, a non-mining company addressed to us, which had a little budget for exploration and for geophysics. The objects were presented in quartz veins within first 100 meters, and the cross-section of these veins are located in thrust zone between the blocks of the indigenous rocks of Triassic and Jurassic periods. The task was simple: to fulfill survey for minimum budget and identify the position of drilling exploratory wells. The depths of upper level of objects is more than 150 meters. So we decided to optimize the work in the following way. In winter period, when the majority of service and geophysical company, including ours, are staying idle, we fulfilled surface magnetic and gravimetric surveys, and it was expected that the blocks that keep the host environment would have different physical properties like density and magnetic properties. And let us have a look at the result of magnetic survey. On the right, you see the SL1 objects covered with metallic constructions. Despite that the survey seems inefficient, but in principle it is obvious that in the southern part in surveyed area we see the trend of amplitude of 1 to 2 nanotesla, which is kind of a continuation of this thrust structure. The result of gravimetric survey inspired us. We see that epsilon object is adjacent to the zone of negative linear anomaly, and it is obvious that at where this zone is doubling. In central part we see wider zone and less contrast, but visible in the south zone. We applied linear analysis of 3D inversion to construct a structural scheme, and we identified 9 areas like that. At this stage, with the purpose of additional optimization, we developed an algorithm for recognition of an image using neural network and machine learning. The idea is to increase the efficiency without increasing the cost of work on additional control. The thing is, interpretation does not the thing is, the interpretation is always subjective, and sometimes people can just omit an object. But here we found the zones that were not very obvious from the first glance. Then, in summer period, we carried out the survey, so we identified the profile of magnetic track rocks, and VP method was successful only in combinations with empty set methods because we have overlap with sedimentary rocks. And the section you see the vertical zone of increased resistivity, where it was our key target for drilling. And as a result of drilling, a golden quartz vein was found with industrial concentrations. So this is an example of successful optimization of work as the most recent outcome. That makes me proud because here investments were very little budget for geophysics one. Well, and the result and commercial size object. Let us discuss about optimization. What is the logical methods of optimization? Actually, it is a combination of technologies, first of all. Always in safety in the field, we have two persons in the field all the time. And it is logical to combine the methods. We can combine geophysical methods and geological and geochemical methods. In 2021, we managed to cover 1,000 square kilometers with surface gravimetric survey, and the pair was of two persons, geophysicists and geologists, that allowed us to construct a reliable structural scheme on gravimetric survey, identify 8 ore fields, and calculate forecasted resources based on geochemical data. We can combine magnetic survey with inductive perforation, and any methods of geology and geophysics can be combined with gamma spectrometrical methods and get a concentration of uranium, thorium, and gallium. We can do it using Mactros spectrometer, and if you are interested, you're invited to our booth, and we will talk more on this technical solution. Non-standard but efficient methods. It seems that to apply surface gravimetric survey to find quartz veins is too little or too much. But thanks to high quality online gravimetric survey, we managed to identify the group electron deposit is surrounded by gravity structures, and having grown the scheme and drilled gradient zones, we found 3 satellite deposits, and a significant increase of resources happened. The second example, when the works are fulfilled with a method that is never counted for this task. This is a magnetic sounding with 40 meter step. Nobody did that before, but at this area we had a lot of geophysics for many years. Different methods have been applied, but in 2013 we managed during 35 days through fulfilling high quality work using this methodology. We could take all this from this method, and we managed to find under the overlaying rocks the isolated zone and northern continuation of a vein zone. As a result, this deposit is under development, and the ore is already concentrated. Sometimes optimization is in improvement of the quality of work. Now we are increasing the cost of certain method, but at the end of the day, we are not losing the object and we are not losing years of work. Improvement of quality is optimization, non-standard way of optimization. Unsuccessful solution, we have a lot of them, but 10 minutes are not enough. So let us talk about UAV, which we also apply. But for certain tasks, this method unfortunately is not efficient. Let us discuss the example of quartz vein zone. with gold intrusions, the results of magnetic survey, and you can see we go up in 40 minutes, but we cannot see the vein zone because the contract the client could lost the object and the investor losing significant amounts just because we used the advantages of new technologies, but we missed the object and the money were lost. So what I would like to say in the conclusion, quite recently I was requested to tell the students in Mining University and show them some successful examples of GM service, and prepared some of them. And it became clear that the most successful results are the results. While we did not fulfill the work based on particular terms of reference, but together with the client we prepared terms of reference, and the process of the work we changed it with the purpose to find commercial object, to find a deposit. What is the conclusion? You should never save on the resources at the stage of creating of terms of reference for planning of work, and that's all. And I would like to thank you for attention and invite you to visit our booth, and we will be always, if you have any task, we always be able to prepare terms of reference for resolving your task. Thank you very much. You provided very detailed and interesting presentation. The next speaker is Director General of Open Geology, Ivan Alexeyev. The topic is experience in prospecting task for or спасибо за то, что
I just started in English and then continue Russian. So very nice to work during this well-organized summit, meet up colleagues, and nice weather in Kazakhstan. Мой доклад является
My report is a logical continuation of Andrei's and Evgeny's presentation. It is great that I can see that we are suffering the same problems in a similar way, and we have very similar experience that we can share. My presentation is a kind of overview of the experience and a little bit fantasy for the future that can be useful for some of you, and you'll see where we are moving with the company. We accumulated significant experience. We have more experience in the Russian Federation, more than 15 years. It's the third year of our operations in Kazakhstan, but still we have dozens of objects, hundreds and thousands geological linear kilometers, thousands chemical samples and deposits, but the problems we always face and client face are more or less similar, and let us discuss it together. So, what is our key task in the process of forecasting and prospecting of deposits? One of the problematic conditions I have provided on the slide. The problem is reliability of the results and restricted resources, time, and funds. These are the specifics of early phase on top of infrastructure problem, remote region, legal aspects of our activity, staffing, and so on. We'll always be working in these resource limitations, sometimes more, sometimes less. And if we have a look at existing approach, cyclical approach of geological prospect and assessment cycle, we'll see the key stages: preparatory, analytical, field works, analytic reports, so on and so forth. All of us know these seasons, love them, and we keep on working with them. And I would like to speak on some bottlenecks. And the questionnaire that we have today is also demonstrative in this sense. One of the most important points here is a preparatory stage, not in terms of development. of terms of reference together with the client, but in terms of the analysis of the massive of data. But pay attention, we have never have been working on just empty place. Even greenfield is always kind of a brownfield, and the volume of information is so huge that we cannot digest it. Just in a giant database, retrospective data, non-connected trusted, connected trusted, reports, article. And before to run and add the information, one should should work on preparing stage, fulfill computer-based targeting, what the colleague were discussing. This is a intellectual work that decreases number of mistakes and costs at the stage of field season. And the next problem is analytics. A lot of modern laboratory methods, ICP mass spectroscopy and its variations, allow us to fill elements at the level of BBB in the third and decimal point. So the spectrum of this element is quite wide. And when we look really at the market of laboratory services in the countries like Russia, Kazakhstan, we come to understanding on the lot. And we understand the speed and we understand the problems that often appear at the computer studies stage when we have sent a sample and the lamp is off and they have to get this lamp from Canada. It takes 6 months. So each stage has its own bottlenecks, and we have to consider it in our work, and we have nothing to do with that. And my ideas on optimization of these prospect cycles and early stages are provided on the slide, and I would like to mention the importance of pre-field solutions before we spend money for field operations. And I absolutely agree with Andrei. The more detailed we pass through the stage of geological survey of area visits and sample collections, the more efficient the stage will be.
And then you can use all distant data that you can get distantly and historical data. At the field stage, we have more than 10 years experience of application different mobile methods, RFR analyzing, combination of different methods, and I'm looking at the geophysics and I envy them because they every day get the information on every day and process it in the field. In geochemistry, we use the same approach because we want to conduct testing using mobile devices in the field, so reducing the timeline for identifying the detailed areas and reducing the time for working inside the grids. Also, we are using mercury measurements when we are working with geophysical equipment together, doing our chemistry, then we can get good results. Last season, we started to apply machine learning methods to process this big data, geochemistry data, but it's a pilot yet. Our approach is during one season, we want to have the geological model, conduct certain activities, and so the same season to go for drilling and checking. A couple of slides. I would like to mention our productive cooperation with our partners from Geoscan. I would like to highlight that we receive high-quality data from our colleagues, and they are very mobile. They can be mobilized within 1 week, not asking where and why. They come and help us to work at our fields in our facilities. If you are talking about geology, geophysics, and geochemistry, in this triangle here, we are developing not only improving the precision of the geochemical assays, but we are using positive methods of MEFA company. We are cooperating with them as well. And actually, they proposed the only way how to identify gold using laser ablation method, using the soil samples. It's not a field method, it's a lab method, lab assay, but it's a very solid and reliable method for testing. But this method is very efficient, and maybe there will be additional presentation about that. But these are the things that I would like to mention, and thank our colleagues, Okay, gas mercury imaging, it proved to be positive as well. For example, it's obvious for the deposits where the concentration of the mercury is very high, but we have lessons learned from Kazakhstan and Russia. Gas and mercury imaging can be very positive in using it in the shears, and we are working on this method also to use it on different landscapes and for different minerals as well. The results are not conclusive yet, but still I believe that this device can be useful in the field, and the results are quite relevant, let's say. Just one last example, we use the Cohen grid here we have about 7,000 chemical tests, and machine learning system reduces the time for mathematical processing, preliminary one, and we compared using the big data. We used the correlation analysis, cluster analysis, and we compared. This is the picture what we need, first results at the first stage, and that's why the results that we got with this method using AI, it's similar to other results of other analysis that can be done. That's very briefly. Thanks again for listening to my presentation. Thanks again. Thank you very much, Ivan. Very interesting, very comprehensive. I can see that you would like to talk more, but we have time limits. And I invite the next speaker. So, Executive Director, Group of Companies, LIMS, Mineralogical Criteria of Ore-bearing granitoid massives. Hello. Thanks for opportunity to speak at this very great conference. It's my second time participating in the conference, and I will be talking about that again. I will be talking about typomorphisms of minerals. It's quite a narrow field, but maybe not related to exploration. I would like to prove it's not like that. I will try to prove that it's one of the most interesting modern developing methods that can help you in your search activities and explorations. I love and like geophysics very much, but I will be talking about other things. I would like to propose you such a concept of exploration and search, in particular for copper and graphite and tungsten-bearing systems. Our concept for surveys is very logical, from regional to local ones. At the regional stage, we identify the types of the ore-bearing systems, and then we identify the ore-bearing levels and rank them. And then when we are doing local prospects, we identify the local structures and also can assess metallurgical resource potential. All our surveys are based on the vast amount of the data from the Soviet Union. You can see these books of our great Soviet scientists. Unfortunately, there was a kind of stagnation in this activity, but now we are mineralogy scientists. We got a great tool. We are talking about mass spectrometry with laser ablation to study the chemical properties of the ore minerals, and it's very relevant now, and you can track it in the publications in the geological literature. I would like to mention the following. The use of zircon as an object to date morphic and of ores, it's not doubtful by anyone, but the volumes from which we are testing the chemical composition, so it's a very insignificant shares of milligrams, let's say. The most modern methods allow us to conduct these tests very fast with high precision, and it's quite affordable in terms of cost. And of course, we and the scientific community propose to use these minerals as an object for geochemical test, not only to identify isotopes and identify the absolute age, but also at the same time doing geochemical test and explain these geochemical peculiarities for exploration and search purposes. So the use of zircon to identify the age of the deposit is increasing every year, hundreds and thousands of tests per year, and calcite, organite, silicates. So for our purposes, we propose to use traditional minerals, titanate, zirconopinite, granite, sheet. Those minerals are proved to be very interesting as well. The list of tasks you can see on this slide, and opportunities are very great here, actually, combining the study of different minerals from the same granitoid massives that are consequent crystallized phases. We can identify a vast number of peculiarities of the structure and metallogeneity of these massives. And the last question that is interested for all the users, how many components, minerals are there, and what are the prospects of this deposit. Now, there are two ways how we can use these methods. Extensive way by accumulating data and building discrimination diagrams, and intensive way we have to search for one mineral and example of that, pyrope. We cannot find such kind of pyrope, but we use a complex of minerals. At the last MINEX meeting forum, I showed this picture. This is in the north of Taimyr in Russia, not studied area at all. We surveyed granitoid massives there, and we identified for the first time in Russia, we identified the resource potential of these massives, granitoid massives, and I would like to report that everything was confirmed. I was surprised myself, but everything was confirmed. All our prospects were confirmed. The second example, sorry. The second example, it's a type of chemistry of scheelite. Very interesting thing. It turns out that mineral looks like quartz, looking similar everywhere. But if we study geochemistry of this scheelite, it speaks a lot, actually. It tells us a lot. On the left chart, you can see the specific example. There was a stream in Kazakhstan dividing the exploration area in two. To the right, so there are scheelites with one nature, and on the left side they are associated with coral and epidermal gold associated. It means that we are reducing the exploration areas twice by just analyzing this scheelite from these two sides. Third example, identifying, this is a standard task, identifying the fertility of the granites, identifying the ore bearing of copper, porphyry, and tungsten systems. Chow diagram that was built based on the study of the Kazakhstani sites, and it is confirmed for tungstite sites and for copper ones and apatites. We just add certain things to these diagrams. To the left, this is the Lu diagram, also very known one that can show the ore bearing of the copper and the copper porphyry systems, one color, and wolfram molybden systems, non-ore ones, proved by the modern systems of the apatite and zircon geochemistry. The fourth example, ideal example, thermometric measurements using Watson thermometric device in zircons and manganese in apatite. You can identify the level of oxidation in magma as a source of the substance. And if we overlap these diagrams, then you can find the area with potential ore-bearing formations. The fifth example, we are talking about sizes. The sizes of the ore-bearing systems, the size and the concentration of the deposit is two different things, but the level of oxidation of rare earth metals, in particular cerium, and I built the known resources of the copper deposit. And here it was a very clear correlation, luckily, but not it's as simple as that. The chart on the left was proposed by the Korean scientists, and they proposed that these highly chargeable elements and rare earth elements correlation, they can provide us with the fields with quite high mineralization. And but I transferred it to my chart, and they were in the different fields. So that's why it's not as simple as that.
But on the other hand, the use of diagrams that have been recently proposed by Song and Mines, the article on oxidation of biomaterials due to the size of deposit, everything seems more or less okay, and that is great. And it also works in the ratio between thorium and uranium, in that sense that, in the sense of potential size of deposit. And our Chinese colleague paid attention that oxidized intrusives have less resources and less capacity for tungsten mineralization. And on the other hand, recovered intrusives have more resources, and they are associated with the deposits with bigger resources that can be well measured if we measure residual magnetic perceptibility. So I would like to finish it. Our company is LIMS, and maybe we are the best in the sphere of mineralogy in Russian, in at least it applied mineralogy, and we are promoting these methodologies, and we are the leaders in Russian Federation in this regard, and we are capable to apply our developments here in Kazakhstan, and I hope it to happen. Thank you, Sergei Viktorovich. In general, I would announce my gratitude to all the speakers that the materials are very difficult and it is difficult to present these materials. But we have found some time to ask questions, and if you have in the audience persons who are desiring to ask questions to a particular speaker, you are welcome to approach to the mic and ask your questions. Good evening. I would like to ask a question to Andrei Fedorovich. Thank you for your presentation. It was very interesting. Sorry if I missed something, but you have presented this information about targeting. Can you just briefly, the square kilometers area, how many persons worked, and what was the period when you finished the work? You said from 200 to 100, and also I have my second question. In your slides, I have seen my idea that I had this idea, but it was not formalized. But thanks to your report, may I approach you and ask my question with regard of pH in water? Yes, 10 minutes is not enough to tell you much, but for one target we spent from 1 to 3 days in Khabarovsk region. The group consists of 2 persons, 2 geologists, 2 pairs, 2 routes, but when the routes were prepared in advance until we have large-scale maps for the route. So you travel in good anomalies. So it took us from 1 day in May. In Malmash we had 15 days. We had 3 geologists and 2 students. The object was huge. And this is so from 1 to 3 and up to 15 days. In general, at average 3 days per an object, and you have to come to the object knowing what has been done before you. And at the exit, you should have an idea whether object is probable or not. This is about the time and square area. Yes, please, you can approach to me at my booth. Thank you for your question. Are there anyone willing to ask questions? Okay, we have one more question, and maybe then we'll close the session. Good evening once more. I have a question in general to all the speakers. In terms of prospecting, it is known the majority of bigger deposits were discovered in 1980s, 1990s. Are there any potential for, to which extent the territory is surveyed in CIS countries? Maybe in there are some areas where which are still uninhabited. To which extent this territory is studied? So now let me respond from my point of view. When I was traveling, when I worked with American company, I traveled to USA and made a report on porphyroid objects in Russia. If you remember, ESGS, they have ocean ring of porphyroid deposits, and so they came to Russia to seek to find. It may not happen that you do not have this deposit or your prospecting was poor. Well, I carried out targeting that all the reports, everything has been found by Soviet geologists, but everything stopped at prospecting stage and recommendation, and then there was no further prospecting of copper because you have Konrad, Malik, Noritsk, so on. Ivan Alexeyev also would like to add to your question. Yes, I would like you and other colleagues who ask this question have a look from some little bit different plane. resolve vice versa tasks, the parameters of what you are going to find. It's one thing. Another thing, the most relevant issue is not prospecting as what we like, but geological, economical assessment. And in every urban region, there are a lot of new technological methods and economic realities because deposit is an economic term nowadays. So with this high mood, so as not to intrude into the agenda of the event, I would like you to thank all the speakers, and I believe it was a very useful and valuable information that have been presented in a very brief way. Thank you very much.